Hello and welcome to Minerals, Rocks, and Fossil Facts. I'm your paleontology teacher, Jen, and it's time for Fossil Friday. Today we're going to be talking about Lepidodendron, or scale trees, which are a primitive lycopodian vascular plant found on every continent, including Antarctica. It lived during the Pennsylvanian period, Carboniferous, for those of you who do not live in the United States and cannot break it down the way we do. So around 323 to 298 million years ago. That means these were alive before the dinosaurs, in case you're wondering. There is no one single discoverer of Lepidodendron, but for a long time people mistook the fossil for giant snake or lizard scales, which is understandable if you're looking at this bark right now. Lepidodendrons grew in tropical wetland coal swamps with other plants such as Sigillaria, Calamites, and Cordaites. Its extensive forests were home to exceptionally large arthropods like Arthropleura and Meganoeura, as well as amphibians like Eriops, who is basically like a crocodile version of an amphibian. They're terrifying and huge. The first reptiles like Hylonomus also lived in the coal swamps, chasing after much smaller arthropods. And the waters were filled with freshwater sharks and lobefin fishes, and they're a bunch of weirdos. Lepidodendron is a tracheophyte, or vascular plant, in the lycophyte division, in the class Lycopsida, in the order Lepidodendrales, and in the family Lepidodendrinaceae. These are long words. There are a number of species recognized, which makes sense because they're found on every continent, which means they're not all going to be exactly the same. They're going to differ on the species level. I'm being slightly distracted. Look at this fool. He's making all kinds of noises as he cleans himself right in front of my bedroom door. Nerd. Lepidodendron were comparable in size to modern trees. The trunks could be as wide as 6.6 feet or 2 meters across and could reach 130 feet or 40 meters in height. Some grew to even greater heights of 140 feet or 50 meters. These are impressively large plants. The bark of Lepidodendron was similar to that of spruce trees, and their leaves were needle-like and densely spiraled about young shoots similar to firs. And honestly, this is probably one of the most gorgeous impressions of leaves, needly leaves I've ever seen. The leaves were only present on young, thin branches, indicating that although it was an evergreen, they did not retain leaves for as long as modern conifers, which is intriguing. Even more intriguing is that during the early stages of growth, Lepidodendron grew as a single unbranching trunk with leaves growing out of the trunk itself, as depicted below. Towards the end of its life, the lower trunk leaves were shed and a dichotomously branching crown grew at the top, as shown right next to me. Like most plants at the time, it reproduced using spores rather than seeds. And Lepidodendron went extinct in most places at the end of the Carboniferous period, but in China they persisted until the Great Dying at the end of the Permian. It was a little bit wetter during the Permian in China than it was everywhere else. It was starting to really dry out during the Permian. Today, most of our fossil fuels actually come from these plants. The dense, waterlogged conditions of these coal swamps prevented the complete decay of the plant matter, allowing for accumulation of thick layers of organic material. This material was then buried under layers and layers of sediment, and the immense pressure and heat from this burial led to a process of fossilization called coalification. And they are now preserved as coal seams, which may look something like this. So you'll have lots of layers of coal, and this little diagram over here will show you kind of the process. Dying and buried and dying and buried. Anyway, you get the picture. Well, thanks for coming to today's lesson. Make sure you tune in Monday to learn about the mineral sphalerite. And have a good weekend. I will fossilize you later.